Alright, a bit of a different video today. We are looking at the idea of relative frequency, also called experimental probability. They mean practically the same thing. The idea is that now we've done a lot of probability now, and we've seen things like when you roll a die, the probability of getting a 1 or a 5 is 1 out of 6. But that doesn't mean that you're guaranteed to get 1 in 6 times, or to get, if you roll it 6 times, doesn't mean you'll actually get one of each number. So this is dealing with what's practically happening when you try this. So that's why I'm not using my normal kind of slides. That'd be cheating. This is going to happen quite live. I have some stuff sort of prepared beforehand that truly randomizes things. That's what this R&D means. It means it's actually random. So we're going to see what happens as we go through this. I can send you this afterwards as well if you want. The number of dice is how many times we're going to be rolling. So right now it's set to 10. So when I roll, it's going to roll 10 times. Now that's interesting. All right, I didn't prepare what was going to happen, so I didn't know what was going to happen. But what we found was we got no 3s, we got no 6s. We got 5 5s, 1 1, and 2 4s. That's how you read this score and frequency thing, right? Because it means we got like a lot of 5s, no 3s, no 6s. And so currently, because we've rolled 10 times and that's what we've got, the experimental probability, not the real probability, but the experimental probability of rolling, say, a 6, right, is 0. Because we didn't get any 6s. So it's 0 out of 10, right? 0 out of 10 rolls end up as 6. Whereas, say, the experimental probability of getting a 4 would be 2 out of 10, because we got 2 4s out of 10 total rolls. Okay, and so you see these ones aren't really that close to what we'd expect. We'd expect a relatively even number, but right now it looks really, really not even. All right, and that's probably because with this number here, we've only rolled it 10 times. Right, you see, if you roll more and more and more, it's going to start looking, look at the graph here, it's going to start looking a little bit more even, right? And our experimental probability has changed now. It's 6 out of 30 because we're looking at the number 4 here, because we've got 6 4s out of the 30 rolls we did, right? And again, the more we do this, the more it's going to look a lot more even. Now, we're still lacking 3s apparently, but doesn't mean that 3 is going to be more likely. It just means as I do this more and more and more, it's likely to even out more. The difference won't be as significant, right? But that's the difference between experimental probability and theoretical. Right? What we've done so far is all just in theory. Right? Is all just a purely mathematical thing. In practice, things might look a bit different. Right? And things tend to, again, match the theory more when we roll more times. So I can crank this number of dice up to, say, 1,000. It's going to take a bit of time to do this, but it's going to do it. Wait for it. And what we find is it is fairly close, right? The relative frequency, or experimental probability, of getting a 4 now is 188 4s out of 1,060, right? There's actually 1,060 rolls here. So look, it goes to 1061 because I've got a header row. And if I change this, say, to what's the relative frequency of a 6 then? Well, I got 158 6s, and so it's 158 out of the 1060 rolls we did. Okay, but look at the graph, it's looking a lot more even now because we've done it a lot more times. That's always going to happen. In maths, we call this the law of large numbers, not the most creative name, but that's what we got to deal with. And so that's, I guess that's what happens when you roll more and more times. Now, let's clear this, and we haven't played with this number 6 here, the faces on each die. So, wow, it's okay. So let's make this number, let's roll a 20-sided die. Some games actually use a 20-sided die. It looks kind of cool. Oh dear, that didn't work so well, but that's fine, it's just formatting. Forgot to put that in. Okay, so with 20 sided die, if we roll 10 times again, it looks like many of the numbers haven't been hit at all. Of course, they can't be. So let's roll it a few more times. What you find that is that it's actually quite uneven. That's because with 20 faces on the die, it's going to be a little bit more spread, and so it might take a little bit longer for it to flatten out. Alright, so right now we've rolled 50 times. What's the experimental probability of getting an 8, for example? With an 8, well, we've got 4 8s out of 50, so it'd be 4 out of 50, 8%. Alright. Right now we've got no 20s, and so right now that probability is apparently 0, right? Even though in theory it's 5%, because everything should be 1 in 20. But we have no 20s yet, and so right now it's still 0. Right? Okay, let's try roll this one a lot of times. Let's go 500 this time. Oops, not this one. This one's 500. Right, this one's still that. So let's go 500. Wow, I've worked it pretty hard. Oops, I pressed it twice. It's gonna do 1,000 now. Oh well, 1,000 is fine. Okay. What you're seeing is that the experimental probability went to 5%. Now, 5% is exactly 1 in 20. Now, this isn't exactly 1 in 20, but it rounds to 5%. Again, things tend to get a little bit closer to what we expect the more times we do it. And so if we go, I'm hoping that if we do this more and more, it's actually going to almost all become 5%. But right now there's a lot of 2s happening. But that's the nature of... Okay, no. I think we're okay. Alright, so that's 5% there. If I go 19, 6%, 18, 5%, 17, 5%. So, yeah, things tend to even out a lot as we roll it like 2,000 times. Okay? Alright, but the big takeaway is this new idea of relative frequency or experimental probability of some event that you're interested in. Right now it's on 15. Is the number of times we got that score, we got that thing we're interested in, divided by over the total number of trials we did. Okay, so if in 96 out of 2050 rolls we got 15, well, that's our experimental probability then. Okay, it's often different to theoretical, but as you do the thing more and more times, it'll get closer. Alright, so that's it. I'll probably upload this. It only works in Excel. I always forget to code in Google. So sorry if you're using a Chromebook or some other device. It only works in Excel. So, but I'll upload it anyway and see what happens. Have fun with it. See you next time.